In this video, we will talk about basic differential equations. So I want to begin with a definition. A differential equation is an equation with a derivative in it. So I want to look at an example. So this is example 2, continuing the numbering of my examples from the earlier videos in this section. So in a previous video we had done, if I scroll it down, we had done example 1. So I'm just continuing that numbering. That's why this is called example 2 as opposed to example 1. Whoops, a little too far. Okay, so we have this equation here and there's a derivative in it. There's actually a second derivative in it. It says f double prime of x equals this polynomial on the right hand side. And then it also gives us two other conditions. It tells us f of 0 equals 3 and f of 2 equals 29. But both of those conditions involve the original function, not the second derivative. So we're going to somehow need to get the original function. Okay, so if I have the second derivative, I can get the first derivative by taking the antiderivative of the second derivative. So I'll take the integral, that's my notation for it, the integral of 5x cubed minus 24x squared plus 2, don't forget that dx. Okay, so I have to do this integral. At this point, I want you to pause the video for about 1 minute to try this on your own. It's really good practice with antiderivatives. 4, 3, 2, 1, pause the video. Pause the video for a minute and see if you can work out what this integral is, what this antiderivative is going to be. Alright, so hopefully you've done that. Hopefully you pause the video for a minute to try this. Okay, so we have f prime of x equals, so the antiderivative of the first term, I'll get 5, reverse power rule, I'll get 5x to the 4 when I add 1 to the power, and then I divide by that new power, so I'll get a 4 on the bottom. Well, the next term, if we do the same thing, the new power is going to be a 3. So the new power is going to be a 3, and I'll end up dividing by 3. So I'll get an x cubed. But when I divide by 3, I'll end up with a minus 8 in front. And then finally, the antiderivative of 2 is 2x. Okay, and then this is a general antiderivative. That's what this integral notation means, a general antiderivative. So I have to put my plus c, plus my constant. All right, so that's f prime, but I need to get f. So I have to take the antiderivative one more time. So I'm going to need another integral, the integral of this time 5x to the 4 over 4 minus 8x cubed plus 2x plus c dx. Okay, I have to do this antiderivative as well. So I'm going to let you try this one on your own first. So pause the video for 1 minute again and try this one. 4, 3, 2, 1. Pause the video. Pause the video for a minute to try this antiderivative. Alright, so hopefully you've done that. Hopefully you paused it for another minute to try this one. Okay, so our integral here, when I do the antiderivative of 5/4 x to the 4, so let's see, I'll have that 5/4 in front, and then reverse power rule will give me x to the 5 divided by 5, so divided by 5. With the next term, reverse power rule will give me an x to the 4, but when you divide by 4, you'll get 8 divided by 4, which is a 2. Okay, with 2x, reverse power rule on that one will give me x squared. And I don't know what c is at this point, so c is just a constant. It's got to stay there. That antiderivative is going to be cx. And then when I do the antiderivative, I end up with another constant. So I can't call it c again because I already have c. I have to call this something different. Maybe I'll call it d. Okay, so that's f of x here. My original function has this form, but I have these two conditions given to me, f of 0 equals 3 and f of 2 equals 29. And I can use those and plug them into this to figure out what c and d are. Okay, so now let's plug in x equals 0 and x equals 2. So technically, in the original problem, the question should have said something like, solve for f of x. Solve for the original function. And that's what we're going to do now. Okay, so if we plug in x equals 0, first we'll end up with f of 0 equals, and a bunch of these terms are going to be 0. The only thing that's not 0 is the d. Okay, so when I plug 0 into this, what is f of 0 supposed to be? F of 0 is supposed to be 3. So that means d equals 3. All right, now let's plug in 2. So if we plug 2 into this, one nice thing that's going to happen is this 5 is going to cancel that 5. And plugging 2 in, we are going to end up with that 1/4 multiplying 2 to the 5th. And then minus 2 times 2 to the 4th plus 2 squared plus 2c plus d, which is 3. And that's supposed to equal 29. All right, and if we simplify this, we are going to end up with 2c equals 46 if we simplify this whole thing. In fact, let me simplify it a little bit before I jump to that step. So 1/4 times 2 to the 5th, that's 8. 2 times 2 to the 4th, that's going to be 32. 2 squared is 4. And then I have plus 2c plus 3 equals 29. And if I simplify this and rearrange terms, I get 2c equals 46. And dividing by 2, we get that c equals 23. So I know what c and d are. I can plug them back in to write my original function. All right, so that'll give us f of x equals 1/4 x to the 5th minus 2x to the 4th plus x squared. Now plug in c, so plus 23x. And then plug in d, plus 3. And that is our original function. All right, so let's look at another example. So I'm going to up the difficulty a bit this time. So this example, this is example 3. Again, just continuing the numbering on the examples from this section. We want to find a function h of x satisfying the following two conditions. So the first condition says h prime of x equals this polynomial. The second condition says that the minimum value of h of x is negative 40. So this is a little bit of review to stuff in the previous calculus class you would have taken, whether it's Math 30 or if you took calculus at in high school or college before this. It's a bit of a review from that previous calculus course. So minimum value means what is the smallest possible value we can get out of h of x. All right, so this is a differential equation because there's the first condition has an equation that involves a derivative. So I know I'm going to have to figure out the original function. So maybe one thing I can do to begin is I can start off by taking the integral. So if I take the integral of x cubed minus x squared plus 4x minus 4 dx, if I take that integral, just doing some basic antiderivatives using a reverse power rule on this, on x cubed I would get x to the 4th over 4. On minus x squared that becomes minus x cubed over 3. The antiderivative 4x would be plus 2x squared. The antiderivative of minus 4 would be minus 4x. And then I need to put a plus c, because the integral, this indefinite integral, means a general antiderivative. So I need that plus c. Okay, so I don't know at this point what this value c is, and I'd like to be able to figure it out, because the ultimate goal of the question is to find h of x. And to find h of x, I need to know what c is. So this is where the second condition is going to come into play. So what I need to find to be able to determine where that min occurs is I need to find the critical numbers. So we need to find critical numbers to determine where the min occurs. So recall, critical numbers are, to find critical numbers, we need to find where the derivative, oh, sorry, it's not f, it's h. Find where the derivative, h prime of x, either equals 0 or the derivative is undefined. Or the derivative is undefined. Whoops, sorry, I'm running out of room here a little bit. Okay, so I'm just scooting that over a bit to give myself more room. Find where the derivative is undefined. Okay, so looking at our derivative is never undefined. The type of thing that could make a function undefined is if there's a denominator, what makes the denominator become 0, or if there's an even root, what makes the inside of the even root be negative. But in this case, our derivative is never undefined. This never happens here because we don't have any of those situations. Okay, so we need to think about when is our derivative going to be equal to 0. Okay, so let's look at h prime of x equals 0. We need to set our derivative, x cubed minus x squared plus 4x minus 4 equal to 0. Okay, so we need to solve this equation. And at this point, this is going to be some review from algebra. So what I want you to do is, first, pause the video for about 2 minutes and see if you can solve this equation. 4, 3, 2, 1, pause the video. Pause the video for about 2 minutes and see if you can solve this equation. Alright, so hopefully you've done that. Hopefully you paused it for about 2 minutes to try to solve this equation. So the key idea for something like this is, when you have 4 or more terms, I'll say 4 plus terms, one technique that's often useful is to try to factor. So try factoring by grouping. That's some review from algebra. So what I'm going to do is I'm going to try grouping the first 2 terms together and the second 2 terms together. And in the first group, what's common? I could factor out x squared. And if I do that, I'm left with x minus 1. And the second group, I can factor out a 4 plus 4. And if I do that, I'm left with x minus 1 again, which is good, equals 0. So the fact that we have the same factor here, this x minus 1 is common to the first group and to the second group, means I can factor that out. We can factor out the x minus 1. And when we do, then we write what's left over in a parentheses. So from the first group, what's left over is the x squared. From the second group, what's left over is the 4. So let me just highlight stuff. So this was a common factor, x minus 1 was a common factor, so we factor that out. And then I looked at the stuff that's left over. X squared was left over from the first group, so I write that as what's left over first. And then 4 was left over from the second group, so then I put a plus 4 in my parentheses here. Okay, and this whole thing equals 0. Alright, so I have this thing factored and it equals 0. So from the first factor, I get that either x equals 1, or from the second factor, we get x squared equals negative 4. But x squared equals negative 4, that doesn't have any real solution. This is, so I'm just going to say this is no solution. In this course, we won't use complex or imaginary numbers at all. So for our purposes, if we get an expression or a number that should be complex or should be imaginary, for our purposes, it's just undefined. So x squared equals negative 4, this does have complex answers, complex solutions. But for our purposes, we're just going to say it has no solution because we just care about whether it has real solutions. Alrighty, so we have figured out the critical numbers. It's just x equals 1. So what I do next is we need to verify that a min occurs at x equals 1. So the question said, like, the minimum value is something. But I can't just assume that at my critical number that there is a min. Maybe it's a max. It could also technically be neither, but I need to verify, what's happening there. So one method for doing this, for verifying this, is to make a sign chart and then include some justification for why that sign chart will show whether our critical number is a min or a max or whatever ends up happening there. Okay, so the way I do this is I make a number line and I put my critical numbers on it. In this case, it's just 1. And then I need to keep track of the sign of the derivative and then what happens with the original function on either side of our critical number. And the way I do that is I pick a test point in each subinterval that's created. So one of the subintervals is to the left of 1. So I pick any test point on that side. So maybe the simplest thing I could pick is 0. It's a nice simple number to plug in. I also have to pick a test point on the other side of 1. So maybe I'll pick x equals 2. So let's remember what our derivative was. Our derivative, h prime of x, was equal to x minus 1 times x squared plus 4. So let's plug in our test points into that. Okay, so first I'll plug in 0. Plugging in 0, we'll get negative 1 times 4, which is negative 4. Okay, so when I plug 0 in, my derivative is negative. And when my derivative is negative, then the original function is decreasing. So it is going down. All right, I also have to plug in the other test point. Okay, so let's plug in 2 into the derivative. If I plug 2 in, I get 2 minus 1 first, which is 1. And then 4 plus 4, which is 8. 1 times 8 is 8. And that's a positive number. So our derivative is positive over here. And if the derivative is positive, the original function is increasing. So it is going up. Okay, so our number line looks like this. So this is where the justification comes into play. So we made a sign chart, this number line and sign chart. And technically, this is a bit of a review from calculus before, or math 30. This sign chart method tests for what are called local mins or local maxes. So because my function changes from decreasing to increasing, and then it changes to increasing at x equals 1, this means there's a local min at x equals 1. But when our problem said, let me scroll to it, when our problem said that the minimum value, the minimum value of our function is negative 40, when it doesn't specify if it's talking about local min or absolute min, it's talking about the absolute. So the number line on its own is just a test for local mins or local maxes. When we talk about absolute mins and absolute maxes, to be able to justify why we have one of those, we need a little bit of extra justification if we use the number line to do it. Okay, so let's write down what that would be. So our function h has an absolute min at x equals 1, since our function h is decreasing for all values of x that are less than 1. So to the left of 1, it's decreasing that whole way, and h is increasing for all values of x that are greater than 1. And what that sentence, this sentence of justification basically justifies or explains is that my graph that I was sort of drawing a rough sketch of up here can't do something like switch and then go lower. Because if it did something like that, it wouldn't have been decreasing the whole way on the left-hand side of 1. Because if I look at this picture now, part of it is increasing. It's increasing for a bit and then decreasing again. And that can't happen. It's got to be decreasing the whole way on the left-hand side of 1. And similarly, it's got to be increasing the whole way on the right-hand side of 1. So that means 1 is where the absolute min happens. Okay, but this sentence of justification is definitely important. We absolutely need this here. Okay, so now we know where that min happens. It happens when x equals 1. So let's plug in x equals 1 into h of x to find c. So we know that the min occurs when x equals 1. And the problem told us what the minimum value was. The minimum value is negative 40. Negative 40, this is the minimum value. And when a question talks about the value, either the min value or the max value, it's talking about the number that we get out of the function. So notice negative 40 is the output. Okay, so let's plug 1 into the original function. So if I plug 1 into h, we'll get 1/4 minus 1/3 plus 2 minus 4 plus c. That's what I get if I plug it into h. And this equals negative 40 on the other side. So where did I get this thing from on the left-hand side? Well, it came from remembering the original function. The original function was this thing after I took the integral, the antiderivative, and I just plug 1 in for the x. Okay, let's scroll it down. Okay, so if we simplify this, 1/4 minus 1/3, if I get a common denominator, this ends up being negative 1/12. And then plus 2 minus 4 is minus 2. And then plus c equals negative 40. So if I get some more common denominators and I isolate for c, c ends up being, so negative 40 ends up being negative 480 over 12. And when I move some terms to the other side, we'll end up getting plus 1 over 12 and then plus 2. But the 2 ends up being 24 over 12. And then combining these, this gives us negative 455 over 12, and that's what c is. So finally, we can write h of x. Thus, h of x is x to the 4th over 4 minus x cubed over 3 plus 2x squared minus 4x. And now I can write what c is. It's negative 455 over 12. And that is our answer. So in terms of our goals for this section, we have finished our third goal, which is talking about what differential equations are, and then we did a few examples involving them. In the next video, we will do an application of antiderivatives to marginal profit.